Welcome to tonight's video on solving trigonometric equations. The first thing you want to do when solving a trigonometric equation is isolate the trig function. So you can subtract 3 sine x. So you get 2 sine x. And then add the 1. And then add the 1. So negative 2 plus 1 is negative 1. And then divide by 2. So you get sine of x is equal to negative 1/2. And remember, to find where the sine of x is equal to negative 1/2, you first want to find the reference angle. In the first quadrant, remember the reference angle and the angle are the same. The second quadrant, you go pi minus the reference angle. Third quadrant's pi plus the reference angle. And the fourth quadrant is 2 pi minus the reference angle. So the reference angle here for the sine of x equaling 1/2, well, if this is the angle, it's opposite hypotenuse, and then rad 3. So this is 30 degrees, which equals pi over 6. Now, where is the sign negative? The sign is negative in the third and fourth quadrants, which means that you take pi over 6 and add pi, so you get 7 pi over 6. And you take 2 pi minus pi over 6 and get 11 pi over 6. Now, because, and let me go back, so you get 7 pi over 6 and 11 pi over 6. Now, because, remember, these functions are periodic, meaning if you add a full circle, you get the same angle. So if you add multiples of 2 pi to both angles, and that's where the plus 2n pi comes in, then you get a same angle. So you could have infinitely many solutions to this. So that's where you have to write the equations. So 7 pi over 6 plus 2n pi and 11 pi over 6 plus 2n pi. Because if you have 11 pi over 6, right, that's 11 pi over 6. If you add another full circle, that's another solution. That's if you add 12 pi over 6, so 23 pi over 6, then you could just keep adding it and adding it and adding it and adding it. And that's what the plus 2n pi stands for, that you could just keep adding a full circle and get another solution. So for this one here, minus 3 sine x. So you get 2 sine x is equal to rad 3. And sine x is equal to rad 3 over 2. And that is where it's 60 degrees, which is pi over 3. And remember, sine is positive in the first and second. So pi minus pi over 3 gives you 2 pi over 3. And to represent that you have infinite solutions, you add the plus 2n pi, because any multiples of 2 pi would be a solution. When you have multiple angles, the first thing you want to do is say, okay, where is the tangent equal to 1? And the tangent is equal to 1 at pi over 4. And remember, since the period of tangent function is pi, we can say plus n pi as opposed to 2 pi for sine and cosine. Now, you divide by 3 to get x by itself. So you get x equals pi over 12 plus n pi over 3. So now it wants all the solutions on the interval of 0 to 2 pi. So what we're going to do is put numbers in for n. For example, if we put 0 in for n, we get pi over 12. If we put 1 in for n, pi over 12 plus pi over 12 plus pi over 3, Remember, that's 4/12, so that gives you 5/12. 5 pi over 12. If n equals 2, then we get 2 pi over 3, which is the same as 8/12. So pi over 12 plus 8 pi over 12 gives you 9 pi over 12. And you should notice a pattern that we keep adding 4 pi over 12 or pi over 3 every time. So that basically means we'd also get 13 pi over 12. We'd get 17 pi over 12. And we get 21 pi over 12. And then 2 pi is 24/12. So if we add 4 more, we get 25, which is too many. So these are all the possible answers between 0 and 2 pi. So for here, sine of x is equal to rad 3 over 2. That means x over 2 is equal to pi over 3 plus 2n pi. And 2 pi over 3 plus 2n pi. So now if we multiply by 2, we get x is equal to 2 pi over 3 plus 4n pi, and 4 pi over 3 plus 4n pi. Now notice when n is 0, we get 2 pi over 3 and 4 pi over 3. But notice if we put 1 in for n, that's too much because it's between 0 and 2 pi. So the only answers are 2 pi over 3 and 4 pi over 3. Solving trigonometric equations in quadratic form, 2 cosine squared plus cosine minus 1. If we remember quadratics, we factor. So the factors of -2 that add to +1 are 2 and -1. So I get 2 cosine x plus 2, 2 cosine x minus 1. Divide the common factor here of 2, so I get cosine x plus 1 times 2 cosine x minus 1. Cosine x equals -1. 2 cosine x equals 0. Cosine x equals 1/2. The cosine of x equals -1 at pi. And the cosine of x equals 1/2. Well, remember, that means 1, 2, so rad 3. So that means this is 60. So it's at pi over 3. And also in the fourth quadrant at 5 pi over 3, because 2 pi minus pi over 3. And between 0 and 2 pi, these are the only answers. You don't need to write the equations when it asks between 0 and 2 pi. All right, the next one we also factor. So the factors of 2 that add to -3 are -2 and -1. So we go 2 sine x minus 2 and 2 sine x minus 1. So when you divide by 2, you get sine of x minus 1 and 2 sine x minus 1. The sine x minus 1 equals 0. So sine x equals 1. Sine x equals 1/2. So that is equal to 1 at pi over 2. And the sine of x equals 1/2 at pi over 6. And also in the second quadrant at 5 pi over 6. Next problem here, we can't factor it, but we can, because there's no middle term, divide by 4 and then take the square root. And remember, when we take the square root, we put plus or minus, so we get cosine x equals plus or minus rad 3 over 2. That means it can be in any quadrant. So cosine is rad 3 over 2. at 30 degrees or pi over 6. So that means we're in the first quadrant at pi over 6, the second quadrant at 5 pi over 6, third quadrant at 7 pi over 6, and the fourth quadrant at 11 pi over 6. If there's two different trig functions in the same equation, one way to solve it is to see if we can factor out a trig function. For example, here, if I subtract 3 tangent x from both sides, I get tangent x sine squared minus 3 tangent x equals 0. So then I can factor out the tangent x. So I have sine squared minus 1. And then I can set both equations equal to 0. So tangent x equals 0. Sine squared equals 1 when I set that equals 0. So the tangent is equal to 0 at 0 and at pi. Sine squared equals 1, so that means the sine is equal to plus or minus 1, which means that it's 1 at pi over 2, and it's negative 1 at 3 pi over 2. So those are your 4 possible answers. If it's not factorable, then I would use identities to make them the same trig equation. For example, cosine squared is 1 minus sine squared. And then you distribute. And then rearrange the terms. And then factor out, divide by a negative. So you get 2 sine squared minus 3 sine x minus 2 equals 0. And then factors of negative 4 that add to negative 3 are negative 4 and positive 1. Divide by 2, so you get sine x minus 2 equals 0. 2 sine x plus 1 equals 0. So sine is equal to 2. Sine of x is equal to negative 1/2. The sine of x can never equal 2. The sine of x equals negative 1/2. Well, sine is 1/2 at pi over 6, but since it's negative, it's in the fourth quadrant. So pi over 6 plus pi gives you 7 pi over 6. And 2 pi minus pi over 6 gives you 11 pi over 6, because it's in the third and fourth quadrant. You would do the same thing for this one, except with the cosine. And I'm going to skip it to go to the next problem, which requires you to substitute in for cosine 2x. And remember, cosine 2x is cosine squared minus sine squared. And then since we have all sines except for that one, we can change it to 1 minus sine squared plus 3 sine x minus 2 equals 0. So combine like terms, you get negative 2 sine squared plus 3 sine x. 1 minus 2 is negative 1. Then you divide by the negative 1 and you get 2 sine squared minus 3 sine x plus 1 equals 0. And then you factor. So the factors of 2, which add to negative 3, are negative 2 and negative 1. So you get 2 sine x minus 2 and 2 sine x minus 1 equals 0. Divide by 2, so you get sine of x minus 1 equals 0. 2 sine x minus 1 equals 0. So you get sine of x equals 1. Sine of x equals 1/2. And so sine is 1 at pi over 2. Sine of x is equal to 1/2 at pi over 6 and 5 pi over 6 because it's first and second quadrant. So those are your 3 answers. All right, looking at the last type of problem here. Well, here we have sine x cosine x equals to negative 1/2. In order to get this to be an identity, because notice we can't split this up, if we multiply by 2, we can get this to be 2 sine x cosine x equals negative 1. Well, 2 sine x cosine x is the sine of 2x. And the sine is equal to negative 1 at 3 pi over 2. And remember, that would be plus 2n pi. And then you divide by 2. So you get x equals 3 pi over 4 plus n pi. Well, when n is 0, it's 3 pi over 4. When n is 1, well, 3 pi over 4 plus pi would give you 7 pi over 4. And when n is 2, 3 pi over 4 plus 2 pi would give you 11 pi over 4, which is too much. So your 2 answers are 3 pi over 4 and 7 pi over 4. Those are your 2 answers. Looking at the last one here, if I wanted to get it to be sine 2x, I would have to multiply by 2. So I get 2 sine x cosine x equals rad 2 over 2. Well, that means it's sine 2x equals rad 2 over 2. Well, the sine is rad 2 over 2 at 2x is equal to pi over 4 and plus n pi, or 2n pi, sorry, and (2x) is equal to 3 pi over 4 plus 2n pi, because in the second quadrant it's 3 pi over 4. Now when you divide by 2, you get x is equal to pi over 8 plus n pi, and x is equal to 3 pi over 8 plus n pi. So when n is 0, we get pi over 8 and 3 pi over 8. When n is 1, we get 9 pi over 8 and 11 pi over 8. And then when n is 2, that would be too much because if you're adding 2 pi. So these are our 4 answers that we could come up with. Going back up to this one here, you see how we had 2 answers because there was only one angle between 0 and 2 pi. All right, that was tonight's video. I hope you were able to learn from it, and have a good evening.